As part of the XL Catlin Seaview survey, we use a camera system called the Seaview II, otherwise known as SV2. This camera system is connected to a diver propulsion vehicle, which allows the diver to travel approximately 2 kilometers per dive. In that dive, we're able to take up to 1,000 images a dive of the benthos, and also take 360-degree panoramic images of the coral reef. The scooter is powered by a propeller which has a battery inside of it, and that battery generally lasts for around an hour, which allows us to travel that distance underwater. Well, traditionally, coral reef ecosystems are monitored either in situ by a diver, where they will record what they're seeing along a linear transect, or divers will take photographs of the reef, which they can then later analyze in a office setting. With traditional methods, we're limited by scuba diving equipment, in that we only really have about an hour to do our dives and our surveys before our air runs out. Whereas with a scooter, the SV2, we can travel 2 kilometers, taking a lot more photographs per dive and gathering much more information about what's happening on the coral reef. We went to the Maldives as part of a research expedition in 2015, and we had the opportunity to lay down a 50-meter transect to take approximately 30 1 by 1 meter photo quadrats, which are cropped later on in the office. And then we analysed them using an online repository called CoralNet, which uses random point allocation on each photograph to determine what is under each point, and therefore get an idea of the percent cover of important metrics on coral reefs, such as coral cover, algae cover, and other invertebrates that we find on the bottom. The exciting thing about the XL Catlin Seaview survey data is that it's georeferenced, and that means that we know within a 5-meter distance exactly where the picture was taken. And what that means is that we have a really good baseline of coral reef cover at sites we've visited, and therefore if a disturbance event happens or an organisation in a country wants to go to that site later on, say 5 years later, but they don't quite have the technology, they can access the global reef record, the Catlin Global Reef Record, and know where a transect was, and go back to that site and take images, and take their own images using conventional methods, feeling confident that the results they get would have been comparable, and they can measure either coral decline or increase.